The chemistry behind stain removal.
Stains are more than just a nuisance. They have distinct chemical structures. Understanding this helps you remove them effectively. Stains are typically caused by proteins, oils, tannins, or dyes. Their molecules bond with surfaces, making simple water insufficient. Effective removal depends on matching the right cleaning agent to a stain's molecular makeup. This chemistry explains why some stains are so tough to get out.
Water-based stains. The role of detergents.
Water-based stains, like juice or coffee, are made of polar molecules. Detergents or soaps are ideal because their molecules have both water-loving and grease-loving ends. This lets them grab onto the stain's molecules and lift them away from surfaces. Using warm water often helps detergent molecules work even better by making stains more soluble.
Oil and grease. Why dish soap works.
Stains stick because they're made of non-polar molecules that repel water. Regular soap won't cut it, but dish soap is specially made with molecules that can bond with both water and oil. These surfactants surround and trap oil molecules, allowing you to rinse them away. Hot water can also make oils less sticky by breaking them up.
Protein stains and enzyme cleaners.
Protein stains like blood, dairy, or egg can be stubborn. Proteins bond tightly to fabrics and change shape when exposed to hot water, becoming even harder to remove. Special enzyme cleaners break down these protein molecules at the chemical level. Using cool water and an enzymatic stain remover is often the most effective method for these types of stains.
Colorful dyes and the power of oxidizers.
Dye stains from things like wine or grass can be among the toughest. Their molecules are designed to stick and show vivid color. Oxidizing agents like hydrogen peroxide or color-safe bleach break the bonds in dye molecules, making them colorless and easier to lift. Always test these products first, as they can also affect fabric color.